My name is Kwang Jino from KIST, and I'll give you a short status report from Korea. Actually, we have two types of machines. One is SMP by IBM, and the second one is Cluster by Oracle. And so the machines were delivered in two phases. In first phase by Gaia is small. It has only 640 cores. And the second phase is around 1500 cores. But it was installed, as you can see, 2007, September. And the second phase is 2009, June. It's kind of old. So actually last month it was retired, and the institute, so this machine will move to another institute in Korea. So the institute was selected this month actually. And then our machine, the second one is Takyuan, now is the main machine. First phase is composed of AMD Opteron, and it has 3,000 cores. And the second phase machine has 25,000 cores. Actually, this is also old. The first one is installed in 2008, and the second one is 2009, and the first one was also retired. And the second one was actually 14th in November 2010 top 500 list, but now you cannot see this machine on top 500 list. So actually the machine peak performance is around 300 teraflops. It's kind of small machine. And we also have the infrastructure for scientific experiment data processing. So we start to build this infrastructure from 2009. So now we have almost 8,000 cores. And for storage, we have 3.3 petabyte storage. So we support ELIX experiment, CMS, Bell and Bell 2 experiment, LIGO and Lino, and an genomic medicine project in Korea. So the researchers from all these experiments can use our resources to analyze experimental data. And we also have a third infrastructure. Actually, we have a partnership for sharing supercomputing resources in many institutes in Korea. Actually, from GIST, KIAS, KOBI, PKNU, PNU, UOS, UNIST, and so on. The system size is small, but we collaborate to build nationwide supercomputing infrastructures. And we try to improve these infrastructures. Okay. So this figure shows number of allocated projects from KIST. Actually, this data shows from 2000. And last year, 2015, we support almost 110 projects from many different scientific fields like mathematics, physics, chemistry, earth science, biology, materials, and so on. Okay. So this is some usage statistics. Actually, most usages come from chemistry and physics, or weather climate modeling, and mechanical aerospace engineering. Actually, chemistry and physics usually use electronic structure calculation and molecular dynamic simulation. And mechanical engineering aerospace usually use computational fluid dynamics. There is a major, application, computational method use our machines. So as you can see, our machine is very old. So we try to procurement. I mean, actually I'm working on a new supercomputer procurement project. Actually, the size is around 25.7 petaflops. So last year we prepared a system requirement specification, and we finished last year June. We finished new buildings for our new machines. Actually, this is a picture of our new building. And July, actually, we passed a feasibility study by most means Ministry of Strategy and Finance. And this year, February, actually, RFI release, we gathered a collected vendors' opinion, and this month we also released RFP draft. We are now collecting some vendors' feedback. So we plan to request next month, July, to PPS. PPS means Public Procurement Service. Then actually we tentative schedule is this year, December, we want to make a contract, and then next year the system will be delivered until September, and then December we expect NOA. And this is our tentative schedule for our new supercomputer procurement. Actually, traditionally, we focused on the traditional HPC, like, as I told you, molecular dynamics simulation, electronic structure calculation, computational fluid dynamics. But for our new supercomputer, we're also trying to support cloud computing, data-intensive computing, and machine learning, and so on. So we design design our machines for this kind of new applications. So this is our schematic target system configuration. Our system composed of computer node and x86 node. This node is just CPU only, and we also have a fan node. This node composed of x86 and GPUs. And also this system connected to storage systems, and we also try to put burst buffers to improve I/O intensive computing. Okay, this is it. Thank you.